Where we left off yesterday was y'all working on the imaginary factors from this set. And so we'll take and work these one at a time. And we'll start off with the x squared plus 4. So when we work this problem, we need to have a is equal to 1, b is equal to 0, and c is equal to 4. We're going to plug it into our discriminant, which is b squared minus 4ac. And so 0 squared minus 4 times 1 times 4. So negative 16. Now, we're going to use that discriminant to go inside the quadratic formula. X is equal to negative b plus or minus the square root of our discriminant, all divided by 2a. And so negative b plus or minus the square root of negative 16. Oops, negative b. I should have put that in as well. So b is 0. Square root of negative 16 divided by 2 times 1, which is 2. So square root of 16 is negative 4, or is 4i, divided by 2. And so we have plus or minus 2i. This is our factor. This is our what the root is. It's not the factor, excuse me. We need to get it to where it looks similar to these. So in order to do that, we're going to have to think back to how we would set up the factor. So if we had x equals 5, then we would write it as x minus 5. If we have x equals I minus or plus I, then it would come down as x minus 1 minus I. So when we have these, we have to take and write them in a way that's going to give us that factor. So we have x equals 2i and x equals negative 2i. And so our factors are x minus 2i and x plus 2i. So when we factor it, those are the two things we came up with. I know yesterday I just got y'all to get it to this point of getting the solutions. Today we're going to take those solutions and go ahead and apply it over. And so let's go ahead and look at the next couple. And so the next one we have is that x squared plus 2x plus 5. And so our a is equal to 1, b equals 2, and c equals 5. And so we're going to go into our quadratic formula and first go into our discriminant. And so b squared minus 4ac. And so b squared is going to be 2 squared minus 4 times 1 times 5. So 4 minus 20 gives me negative 16. So when I go over to my formula, negative b plus or minus the square root of my discriminant divided by 2a. So negative b is opposite of b, so negative 2, plus or minus the square root of my negative 16 divided by 2 times a, which is 1. The square root of negative 16 is 4i divided by 2. And then we divide both of them by that. And so we have negative 1 divided by 2, which is negative 1, plus or minus 4i divided by 2, which is 2i. So that means that my factors are x equals negative 1 plus 2i, and x equals negative 1 minus 2i. So when we move things around, we're going to add the 1, subtract the 2i. And that gives me x plus 1 minus 2i. As one of my factors And the other one, we're going to do the same idea. Plus 1 plus 2i. And so that makes my factors x plus 1 minus 2i times x plus 1 plus 2i. And so now let's go ahead and go to the next one. And we have these two left. And so we're going to be working on the next one, which was, I believe, that negative 12. No, the last two. And so A equals 1, B equals 4, and C equals negative 1. And so when we do this, b squared minus 4ac, so 16 minus 4 times 1 times negative 1. So 16 plus 4 gives me 20. So we're no longer imaginary. That's not an imaginary number when I take the square root of it. So that's the reason we went ahead and moved it over to the real side. We thought it was an imaginary because we couldn't find the factors. But it actually ended up being real. They're just irrational factors. So when I take and find the square root of 20, the square root of 20 is, we're looking for those perfect squares, 1, 4, 9, 16, 25, and so forth, that list that's inside of 20. Well, there's a square root of 4 times the square root of 5, so 2 square roots of 5. So that's what our discriminant is when we actually get through it. So x is equal to negative b plus or minus the square root of our discriminant divided by 2a. So opposite of b is negative 4 plus or minus the square root of 20, which we've already kind of simplified down over here, so I could have replaced that and just had that in that spot, over 2 times 1, which is 2. So negative 4 plus or minus 2 square roots of 5 divided by 2. So that 2 is going to divide in both pieces. So negative 4 divided by 2 is negative 2. And 2 divided by 2 is 1 square roots of 5. You don't have to write that 1. So that gives me my two solutions that are x equals negative 2 plus the square root of 5. And x equals negative 2 minus the square root of 5. And so we have x plus 2 minus the square root of 5 equals 0. And x plus 2 plus the square root of 5 equals 0. So those are our factors. Oops, I put that in the wrong spot. And so our last one, oops, is this guy. So we had the -1, the 6, and the -25. When we work this, b squared was 6 minus 100 is -64. And we get down to -6 plus or minus 8i divided by -2. And so now let's go ahead and write our factors. So x equals 3 plus 4i, and x equals 3 minus 4i. So that makes it our factor is x minus 3 minus 4i equals 0, x minus 3 minus plus 4i equals 0. And so those are our two parentheses. So we're going to be looking at chunking. And chunking says I want to take and look at my first term. What is the square root of 9x squared? It's 3x. Is 3x a factor of 21? So you're looking at 3x times what is equal to 21x. Well, that what, in our case, is 7. So we're going to use this. And I use it called smiley face substitution. I put a little smiley face. If you want to do a Z like the book does, that's fine. But I set my smiley face equal to what I'm replacing. So my smiley face is 3x. So now, I'm going to go ahead and rewrite this. 9x squared is 3x, the whole quantity squared. 21 is 3x times 7. And 10 is just 10. So that's going to give me a smiley face squared plus 7 smiley faces plus 10. So I'm looking to see what multiplies to give me 10, but adds to get me 7. So 2 and 5. So smiley face plus 2 and smiley face minus plus 5. And so my smiley face is 3x. So now, let's go ahead and look at, I keep forgetting to delete out my previous work, doing chunking to factor and find the zeros of number 1. And so I want to look at 25. Can I take the square root of 25x squared? The answer is yes, it's 5x squared. Now the next question, 5x squared times what equals 20x? And that what is 4. So I have smiley face squared plus 4 smiley faces minus 21. And our smiley face was equal to 5x. Oh, that's not x squared, that's just x. So I'm looking to see what multiplies to give me a -21 that has a difference or adds to create, because they're going to be opposite signs, a negative to equal 4. So I need to get multiply to give me negative 21, but add to give me 4. So that would be 7 and negative 3. And so that means that I have 5x minus 3 and 5x plus 7. 5x minus 3 is equal to 0, and 5x plus 7 is equal to 0. And this is going to get us to our spot of where we can equal it. 5x is equal to 3, x is equal to 3/5. 5x is equal to 7, negative 7, and x is equal to negative 7 halves. So negative 7 halves is over here. Three halves is over here. And we know this is positive, so that means that it's going up. And it was even, so I know that it was a parabola. I want you to try to see if you can figure out number 2.